Okay guys, I'm going to review with you our speed and motion graph test. Okay, so follow along with this video so we can identify what the correct answer is for each problem and why the wrong answers are incorrect. Okay, so number one, a student climbed up the hill at a constant speed, stopped at the top, and then ran down quickly down the other side. Which graph below most likely represents this scenario? So what I would like to do is I'm going to identify my information it gives me. A student climbed up a hill at a constant speed. That's what he did first. He stopped at the top. That's what he did second. And then ran quickly down the other side. That's what he did third. But I would like to highlight that it says other side, okay? That's really important, and I'm going to show you why. If I was to graph this on a distance time graph, here's my distance and my time. I don't have any numbers, that's okay. I'm just going to use the lines. So a constant speed means he's moving up and away. But then he stopped at the top. So when I'm stopped, it's going to be a horizontal line. That's for the distance time. And then he ran down quickly down the other side. Now, a lot of students had picked graph A and said that he ran down the other side, so he came back to its starting point. But when you're running down the other side of the hill, he is not coming back to where he started. If it said ran down the same side, then A would have been the answer, okay? But it doesn't. He ran down the other side. Okay, so he didn't come back to where he started. He kept going, which means he is still moving away from his starting point. Okay, so A is not the right answer. B says that he's moving slow. He's getting faster, constant speed, and then even faster. Nowhere in here does it say that he stopped. Can't be B. C, they match. But I'm going to put a question mark next to it because I want to check all my answers. D says that he moved away at a constant speed and he started coming back to his starting point at a constant speed. And then he stopped and started moving away again. So A, I mean, it doesn't even talk about stopping. It just says he turned around to come back. So this one doesn't match, which means C is my only answer. Number two, the graph shows the distance an object traveled in 11 seconds. Here's my distance time graph. Which answer choice best describes the movement of the object between the times of 0 and 6 seconds on the graph? So, that's important. I'm only looking at a specific amount of time. So I'm going to find that time here. Here is 0, and here is 6. And I'm just going to follow it up to where my line is on my graph, which is right here and right here. This is the only part I'm looking at. What does it mean when it's moving away, up and away on a distance time graph? It's a straight line, which means it is moving at a constant speed. Number three, the graph below shows distance over time. Okay, which of these situations could be represented by this graph? Okay, A student walks 1.5 kilometers to a friend's house in 40 minutes. The student then walks another 1.5 to school in 20 minutes. B, a student walks 1.5 kilometers to his friend's house in 20 minutes and then to school in 40 minutes. C, he walks 1.5 kilometers to his friend's house in 30 minutes and then to school in 30 minutes. And D, a student walks 1.5 kilometers to his friend's house in 20 minutes and then walks to school in 60 minutes. Okay, so let's analyze our graph and see which one of these matches. So here's my distance time. Here is where my motion changes. So I'm just going to kind of come down. I want to identify what that time is. So that means it's at 20 minutes. and then it stops here at 60 minutes, okay? And if I go to the left on my y-axis, that's at 1.5 kilometers. And then again at 3, which is 1.5 plus 1.5 is 3, okay? I want to recognize that my total time here is 60 minutes. It took him 60 minutes to go this distance because I'm starting at 0 and ending at 60, so that's important. So let's see which one matches. A, student walks to his friend's house in 40 minutes and then to school in 20. Well, if I look here, this section here ends at 20 minutes. And then he went to school. So this is his friend's house, and this is to school. So those are backwards. They can't be A. Student walks to his friend's house in 20 minutes and then to school in 40 minutes. Walks to his friend's house in 20 minutes and then took 40 minutes to walk to school. And I know that's 40 because my start time is here and my ending time is there. So if I took 60 minus 20, I would get 40 minutes. So this is 40 minutes and this would be 20 minutes. Okay, so it could be B. C says he walked to his friend's house in 30 minutes and to school 30 minutes. Well, nowhere on here am I talking about 30, so it can't be C. And D says he walks to his friend's house in 20 minutes. Yep. And then to school in 60 minutes. Well, 60 minutes is my total. So he didn't take 60 minutes to get to school. He only took 40 minutes. So it cannot be D. The answer is B. Okay. A car travels at a constant speed of 15 meters per second for 2 minutes, then increases its speed from 15 to 25 meters per second during the next minute, and then travels at a constant speed of 25 meters per second for 2 minutes. Which of the following graphs best represent the car's motion during this 5-minute period? So I'm referring to a speed time graph. So I want to identify what each of these lines mean on this graph. That's probably the best way, and then match it to my scenario, okay? So, on A, when I'm talking about a speed time graph, the horizontal line means it is constant. When it's going up, it's increasing, and when it's horizontal, it's constant, okay? B, when it's going up, it's increasing, then it's constant, and then here it's increasing again. C, when it's going down on the speed time graph, that is decreasing in speed. I'm losing speed. Then he's going constant and decreasing some more. And then D represents that he is moving at a constant speed. He is decreasing and then moving at a constant speed again. Okay, so back to my story. The car travels at a constant speed. So I'm going to look for C. For 2 minutes, and then increases, so I'm going to look for an I, for 1 minute, and then travels at a constant speed again. So if my pattern is C, I, C, I'm going to look for the one that matches, and that would be A. A student measured the speed of a toy car at different times as it traveled along the track. She recorded her data in the table below. Which of these graphs does it most likely look at? Well, if I wanted to graph this real quick, this is a speed time graph, okay? Each one is going to represent 0.5, and this one's going to represent 10. So it'll be 10, 20, 30, 40, 50, 60. And then 0.5, 1, 1.5, I know I'm over my letters, 2, 2.5, okay? So I'm just gonna graph this real quick. So when my time is 0, my speed is 0, that means my point is here. When my time is 10, my speed is 0.5, so I'm only gonna come up to where it says 0.5, that's right here. When my time is 20, it's at 1, that's here. When my time is 30, it's at 1.5. When it's at 40, it's at 2. And then when it's at 50, it's at 2.5. If I connect the lines, I have a straight line, which makes D the correct answer. Okay. 6, a ball travels 18 centimeters in 4 seconds. What is the speed of the ball? Well, speed is distance divided by time. So I'm just going to plug my numbers in. This is my distance. This is my time. Okay, so 18 divided by 4. 18 divided by 4 is 4.5 centimeters per second. That should be your answer. Number 7, a block is pulled 0.9 meters, there's my distance, to the right in 2.5 seconds. That's my time. So again, distance divided by time. So I'm going to put 0.90 meters for distance by 2.5 seconds for time. So 0.9 divided by 2.5 equals 0.36 meters per second. 0.36 meters per second. Okay. Number 8, a student walks 2 kilometers in 30 minutes. What is the student's average speed in kilometers per hour? We talked about this. You have to convert minutes to hours first. Well, 30 minutes is the same as 0.5 hours. It's half an hour. Half of 1 is 0.5. So this is my time, and this is my distance. So I'm going to plug in 2 divided by 0.5 because that's my time in hours, and that's what it's asking me. It's asking me for hours. So 2 divided by 0.5 equals 4 kilometers per hour. All right, number 9. A student reads that bobcats can reach speeds of up to 30 miles per hour. What does the speed of the bobcat indicate? This is a tough one because if you understand what speed is, you know speed is the amount of distance covered in a specific amount of time. And I abbreviated them out there. Okay. So if I go through my answer choices, let's see which one matches. A says that the speed indicates the time it takes to reach its maximum speed. So you're telling me that this bobcat takes 1 hour to get up to 30 miles per hour? No, that's not correct. He's not taking that long to get up to 30 miles per hour. That's how fast he can run. So if my bobcat ran for 1 hour straight, he would run on average of 30 miles. So it cannot be A. The total amount of time it travels in one direction. Speed does not focus on direction. It cannot be B. The distance it travels to move between 2 points. No, speed is distance covered in a specific amount of time. It cannot be C. D, the distance it can travel in a certain amount of time. Yes, that is my answer, D. Okay, last one. Use the graphs below to answer the following question. Sequence the 4 graphs in order from slowest speed to the fastest speed. So when you're sequencing, you're basically putting them in order. Okay, so I'm going to look at each graph. I want to identify 1, 2, 3, 4. Pay attention to that, okay? So which one is going the slowest? Well, I can tell that by looking at where it ends, okay? Because the more, the less steep or the more flat the angle is or the line is, the slower it's going. So this one ends at 5 centimeters. This one, in the same amount of time, ends at 15 centimeters. This one, same amount of time, ends at 35 centimeters, and this one is at 30 centimeters. Okay, so you can do this by looking at the numbers or by looking at the graph. And if I want to order them from slowest to fastest, I know I'm going to start with my lowest number. So it would be 5 centimeters, which is graph number 4. Then my next slowest is 15 centimeters, which is number 3. My next slowest is 30 centimeters, which is number 1. And then my fastest graph is 35 centimeters, which is number 2. So my sequence is 4, 3, 1, 2. 4, 3, 1, 2. That's why A is the right answer.